The second half of Chapter 4 deals with system software. System management programs manage the hardware, software, network, and data resources of a computer system during its execution of information processing jobs. Examples of system management programs are operating systems, network management programs, database management systems, systems utility, application servers, and performance and security monitors. Network management programs support and manage telecommunications activities and network performance. Telecommunication networks. Database management systems control the development, integration, and maintenance of databases. Utilities are programs that perform routine computing functions such as backing up data or copying files as part of an operating system or as a separate package. System development programs like language translators and programming editors help IS specialists develop computer programs to support business processes. In this chapter, we're also going to learn, as we discussed, learn about system management programs, programs that manage the hardware, software, network, and data resources, system development programs, which are programs that help users develop IS programs and procedures. We're also going to learn about case tools, which is a method by which end users can develop applications and develop software on their own. As we take a look at system software, we can identify that there's a multitude of layers. First, we start out with the end user layer, then the application software, the system software, and then the computer hardware. As we move down, we see that there's system management and develop software, general purpose, application specific, and then again we hit onto the outside edge, which are users. You've probably all heard of Windows and OS X, iOS, and Android. All of those are operating systems, and as such, their primary purpose is to interface with users, allowing them to use the computer appropriately. The primary interface we have with computers today is called a Graphical User Interface, or GUI. We do not use command-driven systems anymore, although if you go to Command in Windows, you will be taken to the MS-DOS command-driven line. In OS X, there's another way to do that as well, sometimes through terminal. And then there's menu-driven systems. We've gone away from both command-driven and menu-driven systems. One of the primary functions of the operating system is resource management. That allows the computer to manage hardware over the hardware and network resources. And another function of the operating system is file management, which controls the creation and deletion and access of files and data and programs wherever they may be. Another additional task of the operating system is task management, which allows multitasking or the ability to share programs, have them open at the same time, and you can switch between them. There's two different methods of multitasking. One is called preemptive, where each program gets a slice of the time, and cooperative, where programs use the processor when it is not being used by another program. A common operating system function now is called virtual machines, which allow applications to run independently at the same time. This also allows us to run multiple operating systems at the same time. So technically, a computer can run OS X and Windows on the same computer hardware. The most popular operating systems are Unix, which was written back in the 60s and 70s and still is the basic core for OS X. Linux, which is Unix at the core, is open source, it's low cost, reliable, and extremely powerful, and it has a tremendous code base behind it. Then there's also other open source software and operating systems that are very similar to Linux and Unix and have different flavors of them. Other operating systems are Mac OS X, and I don't understand why it has OpenOffice here, because OpenOffice is actually an application suite similar to Microsoft Office. The The chief difference between them is that OpenOffice is free. You can go to openoffice.org, you can download it, run it on your computer without any licenses. Then there's also application virtualization software that allows software to be run in a virtualized platform so that many users can access the same piece of software. And this is how all of our classrooms at APU work. Technically, the software is running on a server back in the data center, and the classroom computers access that server through application virtualization software, thus reducing the number of actual licenses having to be installed on each individual classroom computer. We can share those licenses across the university using application virtualization. There's a variety of utilities that we use to help in managing systems and the data within the programs or within the computer. They are different and separate from the operating system, but they work with many of the features of the operating system to make it easier for you to perform simple tasks. Another type of software is called middleware, and that is the software that works between mostly the computer and networks to ease the use and accessing data and information across different networks. One of the primary purposes of an operating system is to convert all instructions into machine language. Machine language is instructions that are written in binary code, a series of ones and zeros, and that runs directly on the computer processor. Right above machine language is assembler language. This is called a second generation language, and it uses symbols and mnemonics to represent operational codes that then are converted into binary by the assembler, and that conversion converts assembler into machine language. Then above assembler is a higher level languages, which are also called third generation languages like BASIC, COBOL, and Fortran. These programs are then directly converted into binary for machine language without having to go through assembler. So assembler can stand off on its own. Most firmware drivers are written in assembler. Firmware is software that's written for your keyboard, your mice, and printer instructions. To make programming easier, fourth generation languages have been created, and these are non-procedural languages, meaning they tell the computer what to do in more natural terms. And we don't have to be very specific. The computer will figure out and decide how to get there. Fifth generation languages are very close to English, almost conversational and very natural language. Then there's object-oriented languages, which is also a 5GL, or fifth generation language, and it combines data elements in the programs to act as objects, which allows those blocks of code to be reusable. And that is the basis for the programming languages that are used on the internet. The internet is powered by HTML, or Hypertext Markup Language. This is a page description language, and it's not necessarily a programming language, as you have very limited logic and data gathering within it. To allow us to do that, other types of functions that we get in other programming languages, we now have extensible markup language, which also describes the content of web pages by applying contextual labels to the data, which allows us to also use reusability. And then there's something on here that's not represented in the slide, but it's called HTML5. And HTML5 allows us to write web pages so that they can have use in all kinds of mobile devices, and the web page will automatically resize to the different type of device. Also, for internet languages, we have Java and .NET. Java is open source, which is now owned by Oracle, but created by Sun, and .NET, which was developed and is still owned by Microsoft. They are somewhat competing languages, as programmers tend to use one or the other. Java is platform independent, object-oriented programming language, and it's very powerful. Within Java, you can create within both Java and .NET, you can create applets, which are small programs that can be executed by every computer running any operating system. Very powerful. .NET is Microsoft's collection of programming language, and it's available also primarily for web services. Web services is a definition that frequently means that the electronic links between applications and different users can be applied across different platforms. This makes that very powerful and helps us integrate systems much more easily. Here's a diagram that explains the interaction between a user or client application as it traverses through web services and information gets translated and performs the service to come all the way back through to the client application again. So this is an iterative cycle that you do every time you access the internet. All programming languages and programming software are basically language translators. There's two methods in which they do that. One is actually a translation on the fly, and the other one uses what's called a compiler. And the compiler translates the high-level language statements into binary source or object code that runs on the computer directly. The assembler is called a translated language because it translates the symbols and instructions in assembly into machine language directly. So the two different types, COBOL, Fortran, Java, all are compiled based programming languages in that they are directly compiled from their language, their native language, into object-oriented binary code language. Interpreters, which are not used very often anymore, translate and execute one line of program at a time, so they tend to be very slow. So we tend to stay with compiled languages instead of interpreter languages. We have additional programming tools that help programmers identify and minimize errors as they write code. Many of the editors, software programming language editors, have built-in code grammar and spell checks very similar to what you have in Word for the particular language that you're programming in. Then another method for developing software is using case tools or computer-aided software engineering. This allows end users to define what they want in terms of data input, how they want it processed, define the output, and the case tool would automatically generate software for them. This is also very helpful for programmers as they can give the case tool to end users to try and identify easily what they really want to do and what they want the programs to do. The programmer then takes the case tool, reruns it, identifies what the user wants to do, and will either use the case tool output or reprogram it in an object-oriented language that they're familiar with to make it faster and more efficient.